Welcome to the video on the crown ether, which is an extension of the epoxide. So let us define what are crown ether. Crown ethers are a family of cyclic polyether containing 12 or more atoms which are derived from ethylene glycol and substituted ethylene glycol, or we can also call as cyclic polyether with 4 or more oxygen atoms which are separated by 2 or 3 carbon atoms. Crown ethers are the oligomers of ethylene oxide, and these are the cyclic compound with the general formula OCH2CH2 and N. And these are the few examples of a crown ether. And this crown ether, we call it by the name 18 crown 6, 16 crown 5, 16 crown 4, 24 crown 8. The term crown refers to the resemblance between the structure of a crown ether bound to a cation and a crown sitting on a person's head, and hence we call it to be the crown's ether. So, crown ether or cyclic chemical compound that consists of a ring containing several ether groups. Crown ether find the application to form stable complexes with a number of metal ions, particularly in alkali metal ions. The crown ethers are macrocyclic compounds which may contain 9 to 60 atoms, including 3 to 20 oxygen atoms in the ring. And the complexation is considered to result mainly from the electrostatic ion dipole attraction between the metal ion, which is situated in the cavity of the ring, and the oxygen atom surrounding it. The ion pair extraction of sodium Na plus, K plus, and Ca plus 2 with some organic counter ions and dicyclohexyl 18 crown 6 as complex forming reagent has been described. Coming to the nomenclature of the crown ether, the first number here designates the ring size and the second number designates the number of oxygen atom in the ring. In places of an oxygen atom, there can be any other heteroatom like sulfur and nitrogen can also be present. So, if S is the heteroatom, they are called as crown ether. If N is the heteroatom, these are called as crown ethers. So, as said in the earlier slide, the first number in a crown ether refers to the number of atoms in the cycle. So, here we have the number 12. It represents that we have 12 carbon atoms, and the second number refers to the number of oxygen atoms. So, here we have the second number to be 4. It designates that in this crown ether we have 4 oxygen atoms. Likewise here 15 crown 5, it says 15 carbon atom with 5 oxygen atom. And these are the other examples. Here we have 2 benzene, so we call it to be dibenzo. And here we have 18 carbon and 6 oxygen, and hence the name being the dibenzo 18 crown 6. So in the earlier slide, whenever we have a nitrogen, we add a prefix alza. Since we have two nitrogen, we call it by the name dialza. Number of carbon atoms being 18 and number of oxygen atoms being 6, and hence the name of this crown ether will be dialza 18 crown 6. And let us look at a few characteristic features of the crown ether. Crown ether selectively form complexes with metal ions depending on their size and the number of heteroatoms. They form complexes with cation likes Na plus, K plus, Li plus and are useful in the phase transfer catalysis. 12 crown 4 tends to complex with Li. 18 crown 6 is a very good fit for K. Crown ethers are useful for dissolving ionic substances such as KMnO4 in organic solvents. And as I said, they are used in making the KMnO4 to be soluble in the organic solvent. So these ground ethers have a cavities ideal for a complex formation with metal ions. They can even carry metal ions into solution in organic solvent. 18 crown 6 is the right size for the potassium ion and a solution of KMnO4 and 18 ground 6 in benzene. It is often called as so-called purple benzene and it is a very useful oxidizing agent and the high yielding oligomerization is a template reaction with a potassium ion holding the two reagents together. Coming to the application of the ground ether. The ground drift complex is called as an inclusion compound which finds application in many of the reactions. A non-actin is a naturally occurring antibiotic and it has a biological activity to it and it is mainly involved in the electrolytic balance between the inside and outside the cell. So this antibiotic works by developing a gradient with the help of a crown ether and the non-actin diameter specifically binds to the K plus potassium ions and the potassium acetate can be dissolved in a nonpolar solvent such as benzene if 80 crown 6 is added to the solution. So the potassium acetate which was insoluble in a nonpolar solvent can be made solubilized with the help of the crown ether. The crown ether binds potassium in its cavity and the non-polar ground ether potassium complex dissolves in benzene along with the acetate ion to maintain the electrical neutrality. The ground ether is acting as a phase transfer catalyst which maintains the homogeneity between the organic and the aqueous phase for the synthetic work. And this phase transfer catalyst can be applied to many of the reactions like the oxidation reaction, activation of an anion or a nucleophile, and the preparation of diazomethane. And the ground ethers have the unique property of forming a complexes with positive ions like Na plus, K plus, and Li plus. This complexing ability is so strong that ionic compounds can be dissolved in organic solvents that contain some ground ether. For example, KMnO4 is soluble in water but insoluble in benzene. However, if some 18 ground 6 is dissolved in benzene, it is possible to extract the KMnO4 from water into benzene and the resulting is called as a purple benzene which contains the permanganate ion and it is a powerful oxidizing agent for water insoluble organic compounds such as olefins, alcohols, aldehydes, and alkyl benzene. Here, the K plus ion gets inserted into the cavity of ground ether, and the unshaded electron pair of the oxygen of the ground ether solvates the K plus ion, and thus the complex of the ion with the ground ether dissolves readily in a non-polar organic solvent. And these are the references for the preparation of the video. Thank you.